Hello and welcome to today's lesson.
Today you're going to learn about group 1 in the periodic table, the alkali metals.
Everything around you is atoms. It's built of it, the ground you stand on, the air you breathe, and everything.
Atoms consist of protons, neutrons, and electrons. Protons are positively charged, neutrons are neutral, and electrons are negatively charged. Atoms has a core that consists of protons and neutrons, held together by the strong nuclear force. Then there are electrons that spins around the core in different nuclear shells. These nuclear shells are not specific hard shells. It's more like clouds around the core, where the clouds represents certain energy levels. These energy levels are divided into different sublevels. The number of protons improves which element the atom is. So scientists have made a table of all of the elements that they have found. It's called the periodic table, where the elements is in order from small to large, and they are organized by how many protons substances they have. It begins with hydrogen that only has one single proton and an electron. If you continue to look horizontal, you will see the first period of the periodic table. But if you continue to look vertical, you will see the first group of the periodic table. What is common for all substances in a period is that they all have an equal number of electron shells. Common for all groups in valence electrons is valence electrons that is in outer shell. The periodic table can also be divided in 3 parts called metals, which is the largest part of the periodic table, semi-metals that is used a lot in electronics, and non-metals that is gases.
Alkali metals are in group 1, or that's actually not entirely true. Hydrogen is also in group 1, but it's not an alkali metal. The one we are going to focus on today is lithium, sodium, pacifism, radium, calcium, and ferrium. They have all 1 or 2 letters that concludes the whole word, as you can see here. The longer down you get on this table, the more reactivity it gets. And with that we mean that they easily react with other subjects. In different to the long words, these letters are universal and are the same all over the globe. The lower you get on this list, the more reactivity it gets, which means that it easily reacts with other subjects. Therefore, you can find these elements in the salt, medicines, and cleaning advisors. They are also very reactive with water, which makes them easily to find in water solutions and some metal solutions as well. Alkali metals are never alone. They're almost just found together with metals or in water solutions. It's because of their structure, and because of this they have a very beautiful and very colorful flame, as you can see in the picture here, and therefore they are often used in fireworks.
But why does the alkali metals react? Alkali metals has 1 valence electron, which means they have 1 electron in their outer shell. And every atom in every element wants to be perfect, which means they want to have all shells full of electrons. If they have their shells full of electrons, it makes them achieve every atom's wet dream, noble gas structure. The noble gases have full orbitals, which makes them unreactive with other elements. They simply doesn't need any more electrons. By having 1 valence electron, the alkali metals are the most reactive element together with the halogens in group 17. To understand what's coming next, you have to know that water is built up of 1 oxygen atom and 2 hydrogen atoms. When an alkali metal comes in contact with water, it reacts and creates hydrogen gas and a hydroxide that varies depending on which alkali metal you use. That happens because the alkali metals are very anxious to remove their valence electron, and therefore it pushes away one of the hydrogen atoms, which instead creates a bonding with another hydrogen atom that comes from another water molecule. Hydrogen has only one shield with 2 seats, and if 2 hydrogens comes in contact, they share their valence electron with the other hydrogen atom. And by sharing, they reach a full shield and noble structure. Together, they now have built hydrogen gas, which is easily ignited. During the reaction, the electrons are jumping between shells because of the charge and producing heat energy. It goes faster and faster and getting warmer and warmer. At last, it's enough with heat to ignite the hydrogen gas. Now you might be wondering, why does it have a stronger bonding than hydrogen? The electronegativity on these 3 atoms is different. Oxygen has the electronegativity 3.44, hydrogen has 2.1, and all the alkali metals is below 1. The lower in the alkali group you go, the lower the electronegativity gets. Det var det. Oxygen is dragging the valence electron from the alkali metal toward itself very hard. And it can drag the electron using less energy than it could when hydrogen was attached. And due to the big gap between the electronegativity, the alkali metals react very easy with other elements. To sum it up, the alkali metals is in group 1 here in the periodic table. They have very low electronegativity and they have 1 valence electron, which makes them very reactive with other elements in the periodic table. And I hope you've learned something from today's class, and that's all from us.